Hello guys, another video of the series Control Rig, and the idea is that I'm gonna try to deliver a video, and in each video I'm gonna try to build simple solvers each time, trying to convert what I know about rigging into this new realm that I'm still learning, which is Control Rig. The idea is that I want to end up with a nice and solid and robust library of solvers that are really simple and atomic on their own, and then in the end moving into something more complex where we assemble these solvers together to build a behavior that is a little bit more interesting. So today we're going to look at something extremely amazing, is what I call the FK solver, which is basically a chain of bones that rotate around. But the reason why I want to do this simple thing is because it's an opportunity for me to introduce the concepts that the new Unreal has introduced in Control Rig, which are collection, loops, branches, etc. And spaces, another topic I haven't touched yet. So let's jump into Unreal. This is a skeletal mesh in the same identical thing, it's only 4 bones. And this is the object, nothing much. And the first thing I would like to point out is that we have these new icons here, and these are called spaces. You can create a new space and parent whatever you want. You can create a space underneath there. What is a space, and why am I using it in this specific example? We're gonna get why I'm using the spaces, but what is it? It's basically a new coordinate system above the object that you're currently manipulating. So if this control, it's a new coordinate system. In order to create a new Euler coordinate, you would simply parent this thing underneath a group or something else. This will be the child, this will be the parent. The parent is what you would use, the parent not having any shape under this transform node. It's invisible, and this would represent a coordinate system where you can drive something that is a child of it. Let me parent that. So this is the simplified description of what a space is. I don't know exactly why they may. I think this is simply a transform. Exactly structurally what's the difference between a virtual bone and a space, I'm not sure. Potentially it's API and things, just to keep things organized. But I mean, to me all of these are a series of transforms, in a hierarchy. So I could potentially swap this space for another control and make the control invisible. To me, in my brain, this is how it feels anyway. I'm using spaces because spaces are provided as a unit structure, and it's really nice to filter them out through this, which I'm going to explain in a minute. So there it is. That's what I think the space is. And remember, I'm still learning. This is me guessing constantly. So to me, space is a new coordinate system above, and in the first part, in the setup event, like we saw in the other videos, this is where I'm basically trying to automate the snapping of the controls without me have to manually go and place them. The only one I place manually is this one, but we'll see in a minute what this does. So what I'm doing here, if I have created a variable, this is not supposed to be there. I created a variable called partial name, which happens to have the name FK solver. And again, the reason is I'm exposing this as a variable in case I want to reuse this viral somewhere else, even if it's not necessary, because the graph is compiled. The compiler will take care of all the static data. But the reason why I'm using it, it's once for readability, and second, if I want to reapply this as a module within a more complex scenario, so I can change things and name of bones from the very beginning. So this is simply a string, and the string says FK solver. Then we have this new node which says find everything that is a bone that also has that string as part of its name. So and give me a collection in return. Now a collection In Python this will be a list. I think it's a list, and or you know, an array. This is a new word, a collection, and I think it's because it's a collection of objects that have properties, and I don't know if there is a clear distinction, but this is what it is. It's a list of objects. This is the filter, and that's why it's really nice to use spaces, bones, and controls, because you can filter them out through here. So what this gives back me in return is basically all the bones that have this partial value in it. So FK solver. So collection here is these 4 bones. If you watch this value, you will see that it's a key collection structure. If you watch this value, you should see it's a key collection structure. If you watch this value, you see that they start populating this thing. These right-click, watch this value, are really nice, especially when you have to deal with lists and loops. And this is something that for this kind of visual debugging helps development and speeds it up quite a lot. It helps a lot when you're learning new nodes and stuff like that. You can check values, you can check the content of the list. So that's really cool. So again, we have a collection, and this collection says these 4 bones. Then we have this is a loop that says go through each individual bone, and for each element replace every time you find an envelope or _m, substitute, generate a new string name that contains the word space. And guess what? We have FK solver 00n and FK solver 00 space. So in one go, in just 2 nodes, I'm getting these 4 and this 4 in a loop, which is absolutely awesome. So I get this name, but also on the item, so basically this item, this item, this item, and this item, I'm getting, within the loop, I'm getting the transform. And by using this as a replacement, I find a new item, and in each time I'm setting the transfer of this space from the bone I just found. So this item, it's now connected to this item is connected to this item, and so on. So you see that the controls are children of the space in each one, are now basically in the right place. And if I were to change, the reason why I'm using these and not, again, I said that in the other video, and this one I feel I want to repeat myself a bit. The reason why I'm not doing this, I create a collection with hard-coded data, is because this graph would work if suddenly there is a fourth joint underneath, and a fifth, etc. Because I'm looping through using a rule instead of hard-coded names. This is it. This is pretty much it. I'm setting the space based on the bone position, and that's where I get these controls. Now, if I select this control here, you can see that basically each control has this rest position, the offset transform, everything is at 0, and the reason is the parent is exactly on top. And by the way, if you want to see where there is no easy way, well, there is an easy way to show them, and I'm going to show that in a minute. But if you select the spaces, you cannot visualize the gizmo. I couldn't find any options in the details panel, but you can simply say draw transform, and you can say this is not supposed to come from there. Draw transform, and you can say get transform here. Get transform. I want to get this transform here, and then I want to draw this transform in viewport, and then it's going to happen afterwards. So no, sorry. Oh, sorry. Yeah, no. Okay, good. This happened because, so remember, this is the setup event, and the setup event only ran once, and then that's it. So this, in order to see this, we actually need to jump into forward solve. I apologize. We'll see this later. So okay, so right now I have all the controls in place. if you remember from, I just want to make an observation, take some time here to make an observation. Last time, in the last video, I said that the spaces are not really necessary most of the times, but I wanted to make this example precisely for this reason. Because each transform, each control, has the offset transform. So you could potentially say set control transform. Sorry, set control offset, not control transform, offset. And you see that it sits under setup. So nothing would stop me to do this instead of using a space, so the hierarchy would be much simpler. The problem is that I believe that this node, the way it behaves, it seems like this node is really being used for a setup. It doesn't give proper info down the line, as if you cannot change at runtime the control offset. I need to dig a bit more into this, but this is the reason why I'm using a space, and I believe this is the right way, because the space will also allow you to easily blend between things. So you could set the control offset and avoiding the control space. The position it will work. What it won't work, it's stuff below. So a lot of words to show an FK chain. I'm very aware of that, but still, I think it's worth it. So now we have the controls in the right space. Then I build example number one. Example number one, it's something that basically doesn't use any of these controls I've just made, but I just want to talk about it. About this node, distribute rotation. Distribute rotation, each rotation is expressed by quaternion and a ratio, where the ratio is between 0 and 1, so you can distribute the rotation along the chain based on the ratio. And basically what I'm doing here, I'm very easily getting all the bones specified by this rule and getting this rotation control, and I'm saying distribute the rotation of this control along these bones, and this is the behavior that you get. So I wanted to show this because distribute rotation is a really cool node, and I've used it in other scenarios, but I still like to have control over the way I'm performing rotation and calculation of matrices. And on top of that, I noticed that you see this behavior here. If instead of using bones I would use controls, I get this accumulation of rotation, and I still don't know if I misunderstood the way the node works. I flagged this to Epic, and maybe I'm completely wrong here. Not gonna lie, but I don't think this is a good behavior. I think this is potentially a bug, as if this distribute rotation is only expecting bones, but really what it's doing is distributing a rotation through transform. So this to me should still work if with different things. And it's nothing to do with the spaces. If you were to take the control out of the spaces away and keep the controls, it would behave the same. There is some kind of accumulation happening. With the bones it doesn't work, but I wanted to talk about distributed rotation because maybe this is all you need for your rig. But this is not what I wanted to have both things. What I mean by both things, let me disconnect that. The very second thing that you could do, it's very simple, and you get the name, you search for controls, and for each control you substitute control with bones. So basically it's totally the opposite of that one, and then basically now the control is driving the bone. What you get, because these controls are in hierarchy, is an FK chain. Alright, so far I haven't been using the spaces. The spaces comes really handy now at the very end, which is really when I wanted to, the final, to me this is the final product of this solver, which is really simple. So if I detach this forward solver and attach this forward solved, you can see that this graph here is exactly this graph here. I could comment this saying attach controls to bones. If I were to take this entire box with this one included. Oh my goodness, I'm making a mess. If I were to take this box here, this would be exactly the content of this box. It's literally nothing different. Taking the name, control, substitute the control environment, get the bone, connect the bone to the, connect the control to the bone. That's it. Before that though, I am doing something to, let's assume that this is a finger or a tail. Actually, let's assume this is a tail. And you want to quickly animate the tail up and down, but then the animator wants to offset the pose from there. So you get you have a control to really do broad motions, and then you fine tune it if you want to add a little bit of delay. Now I'm very aware that we have delay mechanism in control rig. We're going to touch that later on because I don't feel confident enough until I understand the algorithm behind it to talk about them, the solver, the simulation nodes. But yeah. So you can see that now we have a very nice control, and the way this is working is that if you notice it, if everything is at 0, this control is still at 0, which is really nice for the animator to know where is the starting point. So the way this works, it's simply you have a forward solve, but instead of taking the global space from the control, you're taking the local space and apply to the space, because this is always the same name but is filtering out the spaces. So at this point here, see if it tells me, see I have these spaces here, and I have these spaces here, and I am connecting the rotation of this guy to the parent of each control in local space, and by that what I'm gonna get is basically rotation on every single thing. And at the very end I'm attaching these controls to the bone, so the final behavior is that you get an FK chain that you can easily manipulate, and then you can offset, and you're still able to manipulate it. This is pretty much it. I'm just curious to do something now. I wonder what happens, because this is basically the ratio. So this is goes from 0 to 1 based on or based on the number of things in the collection. Wonder what happens if I connect the ratio to the weight. Yeah, I was kind of expecting this. This is live. I haven't prepared this, I promise. But basically, what this does, it rotates more towards the end. So with this way, this is the way I would rig a tentacle, where you have a lot of segmentation at the very end, really fine-tuning controls, and you have more rigid at the very beginning. And this is very similar to what the distribution node does, although the distribution node has different options to interpolate this rotation along the curve, which gives you much more cool controls. I hope this was helpful. I know this was very simple and a lot of words, but we're gonna get into something more interesting soon. Bye bye.